Okay, that may have felt like a little bit of a detour. We started talking about adding fractions, and then I started talking about least common multiples and all that sort of stuff. But the reason this is important is because when we're adding two fractions like these are unlike fractions, then the fractions that these can become are each multiples of these denominators. So this can become some number of 12ths, or it can become some number of 18ths or 24ths or so on. Those are exactly the multiples of 6. And this one can become the multiples of 8. So what I would want to do is I would want to figure out what is the least common multiple of 6 and 8. Well, this is exactly the problem we've been addressing. 6 is 2 times 3, 8 is 2 times 2 times 2. So my least common multiple here, let's see, it looks like I need 3 copies of the 2 and 1 copy of the 3. 8 times 3 is 24. So my least common multiple here is 24. The reason I care about that is because now each of these fractions can be converted so that they have a 24 in their denominator. This is something over 24, plus this one being something over 24. And actually, I should give myself a little more room than that. 1 over 6 plus 5 over 8 equals something over 24 plus something over 24. Like I said, I can convert each of these so that they have that 24, because 24 is a multiple of both 6 and 8. It is a common multiple. And not only that, it's the least common multiple. It's the smallest number I can do this with. And that's handy because it makes things easier to work with. Alright, so what number times 6 is equal to 24? Well, 6 times 4. I do the same thing at the top. This is the just rewriting fractions so that they have the same denominator, or so that they have a specific denominator. This one, if I have an 8 and I want it to be 24, I need to multiply by 3, because 3 times 8 is 24. I'll do the same thing to the top, giving me 15. And then I have now I have 4 over 24, 15 over 24, which I can combine to give me 19 over 24. At this point, I would want to look to see if I can reduce my fraction at all. 19 is actually on my prime number list, and it's not divisible, not a factor, rather, of 24. So this is in lowest terms. You do want to be careful, don't reduce these things as soon as you see them. If we had reduced this down, let's do this one, would be easier. If I happen to notice that both of these were even and I started reducing this fraction the moment I wrote it down, I would actually get it back to 1 over 6, and, well, that wouldn't be very helpful. I need it to be over 24, at least temporarily, so I can add these two fractions together so that they have the same, so that their divisions, their level of division lines up. That's, kind of thinking about what's happening here. We have some number of sixths and some number of eighths. And what I'm doing is we're subdividing these. I had to divide each of these up into 4 equal parts. 1, 2, 3, 1, 2, 3, 1, 2, 3. So divide each of these up into 4 equal parts, and divide each of the eighths up into 3 equal parts. And in doing so, I had 1/6, which was, I don't know where that was, something like this. And I had 5/8, which was probably somewhere over here. I don't remember where it was exactly. I should have shaded before I subdivided. But now each of these spacings are 24ths. They all line up. So that's what allows me to now add these things together and say I have 19 of those 24ths. All right, 3/8 plus 1/4. I don't even really feel the need to mess around with this one too much, because I can see that if I was to double this 4, I would become an 8. That is my least common multiple, so that's what I'll just go with. I'm not going to fight it if I can see an easy way to do this. The 1/4 becomes 2/8 if I just double both the top and the bottom. Now, when I add these together, I get 5/8. Okay. When we have multiple fractions, again, it's not really that big of a deal. Just like when we had multiple numbers we're finding the least common multiple of. Let's see, 6 is 2 times 3, 9 is 3 times 3. I don't know why I did these in a different order. Least common multiple, let's see, I need a 2, and I need 2 3s. This one said I needed a 2. This one said I needed 2 3s. If those are true, I make everything else happy. So let's see, this is 18. So that means I can convert all of these fractions so that there's some number over 18. 1 over 6 plus 2 over 3 plus 5 over 9. Again, I'm leaving a little bit of room here so I can see what I'm multiplying each of these by. This is something over 18 plus something over 18 plus something over 18. Let's see. For this first one, if I want it to become an 18, I need to multiply top and bottom by 3. So that'll be 3 over 18, because 1 times 3 is 3. For this one, I have a 3, and I want it to become an 18, so I need to multiply top and bottom by 6. 2 times 6 is 12, so that's 12 over 18. And this one, I'm starting out with a 9. I want it to be an 18, so I'm going to multiply top and bottom by 2. 5 times 2 is 10, so that third fraction becomes 10 over 18. Now I can add these together. That's 15, 25 over 18. And I would want to look to see if I could reduce my fraction. But 25, the only prime factor there is 5. 5 is not a factor of 18, so that would be my final answer. Let me look to see if there's more. There are. Okay. If we're dealing with mixed numbers, again, just like we saw with the mixed numbers previously, I would probably begin here just by converting everything into fractions. So to start off, we take 2 times 8 is 16. Add that to the 3, we get 19 eighths. Here we get 18 plus 1, which is 19 over 6. We need the denominators to match up. We don't care about the numerators. So that means I need to find the least common multiple of 6 and 8. 6 is equal to 2 times 3. 8 is equal to 2 times 2 times 2. So my least common multiple is 2 times 2 times 2 times 3, which is 24. Alright, so that means I can convert both of these fractions to something over 24. 19 over 8 plus 19 over 6 equals something over 24 plus something over 24. Let's see, this one, if I'm starting out with an 8 and I want it to become a 24, I need to multiply by 3. 19 times 3, it's 57, just less than 20 times 3, so I just kind of did 20 times 3 is 60 and corrected it, brought it back down to 57 there. 6 to get it to 24, I need to multiply by 4. Again, I'm going to do the same sort of trick here. 20 times 4 is 80, but that's overshooting a little bit, so I'll bring it back to 76. 57 plus 76, I'm not even going to bother. I'm just going to do this. 57 plus 76 is 133. So now you may be wondering, how do I check to see if there are any common factors here to write this in lowest terms? Well, fortunately, we actually have the prime factorization of 24 written over here. We just figured it out. So we can see that only 2's and 3's go into 24. Clearly 2 doesn't go into 133 because it's not even. I can check to see if 3 goes in. 1 plus 3 is 7, and that's not divisible by 3. So this is actually in lowest terms already, 133 divided by 24.